Welcome back to another video. In this tutorial, we are going to dive into the ultimate truth of sine squared theta plus cos squared theta equals 1. Okay, so we are aware that this identity over here is equal to 1. So we want to show the proof. And the trig ratios, we have to know that the trig ratios are defined with respect to the size of a right angle triangle. Okay, so let's have an illustration of a right angle triangle. This is a right angle triangle, okay? A right angle triangle labeled A, B, C. Okay, so let's name this distance A, this distance B, and this distance C. Okay, so you are aware that the longest part of the right angle triangle is your hypotenuse, right? So your hypotenuse is here. And the side opposite to the angle is the A. So we have this part to be opposite, right? And this side is our adjacent. So that is basically the labels, okay? So we want to prove using this figure to prove this identity. Okay, so we know about SOHCAHTOA, right? SOHCAHTOA, right? So the so over here just signifies sine of the angle, and the O is opposite and the H is hypotenuse, right? So sine theta, sine of the angle, is equal to opposite over hypotenuse, right? So we have that, and we know opposite over here as A. We know hypotenuse as C, right? So basically, we're going to have sine theta equals A over C. But don't forget that by Pythagorean theorem, if you want to find any side of a right angle triangle, then you say that c squared, the longest side, right? Square of the longest side equals the sum of the other side, the two sides, right? So right here we have this. So this is here, c squared equals a squared plus b squared. So this means that we can say that c is equal to square root of a squared plus b squared, right? So we have that. So simply we can say that sine theta is equal to a over square root of a squared plus b squared. We have that. Okay. So once we have sine theta equals this, then we can also go ahead and talk about the sine squared theta. Okay, so sine theta, we have sine theta, right? So we can talk about the cos theta. Okay, so cos theta, that is basically the cut, and the CAH, C is cos, the cosine of the angle, and the A is adjacent, and adjacent over here is B. So we have B over H. H is hypotenuse, and that is C. And from here, we know that C is square root of A squared plus B squared, right? So we have cos theta equals B over square root of A squared plus B squared. Wow, that is interesting. So we have this here, and we have these two here. The rest is substitution. Let's dive into it. So from here, once we know that this is this, cos theta equals B over square root of A squared plus B squared, and sine theta equals A over square root of A squared plus B squared, then we can do something in here, right? We can do something in here. Okay, so let's consider this as equation 1 and consider this 2 as equation 2. Okay, we consider that. Okay, so we are using equation 1 and equation 2. So we are using equation 1 first. Okay. Okay, so from equation 1, let's write it first. Sine theta equals A over C, right? So let's square both sides. Of equation 1, right? So when we do that, then we are going to have sine squared theta equals A squared over C squared. That is interesting. So basically, that is going to give us, so let's consider this as equation 3, right? And also equation 2, from equation 2, let's do the same work by multiplying, squaring both sides. Let's square both sides, right? So when we do that, we are going to have cos squared theta equals B squared over C squared, right? So we consider this as equation 4. Okay, so once cos squared theta equals B squared over C squared and sine squared theta equals A squared over C squared, then why don't we add them? So adding equation 3 and equation 4, adding 3 and 4, okay, we're going to have we're going to have sine squared theta plus cos squared theta equals A squared over C squared plus B squared over C squared. That is interesting. So we have here sine squared theta plus cos squared theta equals, find the LCM for this, you have over C squared, right? So this goes off, so we have A squared here plus this also goes off, so we have B squared here, right? That is great. So come back here, okay? Come back here, and from here, you can see that from the Pythagorean theorem, C squared is equal to A squared plus B squared. So we're going to substitute C squared with A squared plus B squared. So let's do that. So we're going to have sine squared theta plus cos squared theta equals A squared plus B squared will be substituted with C squared. So we're going to have C squared over C squared. That is interesting, right? So this cancels this, and we have that equals 1. So swift. So that is basically telling us that sine theta, sine squared theta plus cos squared theta is equal to 1. Hence proved as required. Hence proved as required. That is the process. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'm going to give you more updates. Bye-bye.